This is for Year 12 Specialist. It comes out of 6G. It's 15C. Sketch the graph of the following, labeling the x-intercepts, turning points and asymptotes. And here it is here. Okay, so if I was to expand the top and the bottom and then do a division, x squared goes into x squared once. That's nice, the x squared and the x term disappears to leave with minus 2. So I've actually got 1 minus 2 over this. So I've got the addition of a linear of 1 and this reciprocal parabola that's been multiplied by negative 2. So let's just consider the denominator. That would be a parabola that goes through at 0 and at 1 and is positive. So this point here is at a half. So a half minus 1 is a half times negative a half, it's negative a quarter. So if I wish to do the reciprocal of that, this is going to go up to 4. Sorry, the reciprocal of that's going to go down to 4, negative 4, and it's going to look like this. An asymptote, and this will be there and that will be there. However, that gets multiplied by negative 2. So my 4 should go up to 8, and all of this will go up to there, and will be down here and down here. And then when I have 1 added to it, all of it gets moved up 1. So when I have my 1 added to it, I should have an asymptote over here at y equals 1, because everything gets moved up by 1. I'll have an asymptote at x equals 0 and at x equals 1, and I will have a turning point which should be at a half and 9. It should be 9 because this negative 4 becomes negative 4, goes up here to be doubled, so negative 8, and then, sorry, positive 8, then plus 1 makes it up at 9. So I can double check that. So my curve should look like this, and I'll have this, and I'll have this, and I would like to find these x-intercepts. So I go back up to my original, and I'm going to make my original equal to 0, and that should find my x-intercepts. I'll ignore the denominator. It's only when the numerator is equal to 0, therefore x equals 2 and negative 1. And I like that because there it is at 2 and there it is at negative 1. So I've got my x-intercepts, I've got my asymptotes, I've got my turning point. I'm just going to confirm that the turning point, there is only 1 and that it's at x equals a half. So I need to take the derivative. I've got the quotient rule. So u equals x squared minus x minus 2, therefore u dash equals 2x minus 1. V equals x squared minus x, and v dash equals 2x minus 1. So y dash will be v times u dash, so x squared minus x times 2x minus 1 minus u times v dash, so I've got 2x minus 1 times x squared minus x minus 2 all over x squared minus x squared. And to simplify that, I'm going to have a common factor of 2x minus 1. So 2x minus 1 outside of x squared minus x, and then minus x squared minus x minus 2, which is 2x minus 1. X squared minus x squared disappears, minus x plus x disappears, minus minus 2, and I have a 2 there. So the derivative y dash equals 2x minus 1 over x squared minus x squared. And if that equals 0, that only happens when my numerator is 0 and 2x minus 1 equals 0, therefore x equals a half. So I'm in agreement that this is going to be the only turning point. And that's what the graph looks like.